I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Algebra, Unit 8, Lesson 4. We're going to look at how to solve quadratics using the quadratic formula. Remember, when we're solving a quadratic, we're looking for the x-intercepts, which can also be called the roots, the zeros, and the solutions. So the quadratic formula is this formula right here, which is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The plus or minus is important because when I take the square root of 16, my answer could be 4 or my answer could be negative 4. Why? Because if I square 4, I get 16, but if I square negative 4, I also get 16. So there's two answers there. And remember, we know that in a quadratic function, it's possible to have two solutions, and that may be because of the square root and that there's a plus and a minus. Remember, the standard form of a quadratic function is ax squared plus bx plus c equals y. And when we're trying to find the solutions, we need y to equal 0. And so we want the equation to look like this except equal to 0. So that's where we're going to look at. So the first equation here is 2x squared minus 3x minus 5 equals 0. So it's already set to equal 0. So we're ready for that. So I'm going to identify A is 2, B is negative 3, and C is negative 5. And now I'm just going to plug it into my formula, and I'm just going to rewrite the formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So here we go. X equals negative 3. Okay, negative b is negative 3, plus or minus the square root of b squared, that's negative 3 squared, minus 4 times 2 times negative 5. Notice I put that in parentheses. All divided by 2 times 2. So I'm going to simplify the negative b, so that's going to be a positive 3 plus or minus the square root of. So I'm going to square the negative 3 first, which is 9, and then I've got negative 4 times 2 times negative 5. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is a plus 40, all over 4. So that leaves me with 3 plus or minus the square root of 49 over 4. So from here, I'm going to split this into two problems. The first one will be x equals 3 plus 7 over 4, because the square root of 49 is 7. And the next one will be x equals 3 minus 7 over 4. 3 plus 7 is 10 over 4, which is 5 over 2. 3 minus 7 is negative 4 over 4, which is negative 1. So my two solutions are 5 over 2 and negative 1. I would write them as ordered pairs, representing the x-intercepts. Those are my two solutions. So in this example, the number under the square root was a perfect square. I'm talking about the 49. So it made things pretty easy. That number will not always be a perfect square, which is actually why using the quadratic formula can be really helpful when our numbers are not rational numbers. All right, let's look at the next example. What I notice here is that it's not in standard form, it's not equal to 0. So I'm going to subtract the 4 and subtract the 7n on both sides, which is going to give me 9n squared minus 7n minus 4 equals 0. Now I'm ready to solve. I'm going to write down my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My A is 9, my B is negative 7, and my C is negative 4. This is why it's really important to write it in standard form before you start solving, so you don't screw up on A, B, and C. X equals negative 7 plus or minus the square root of negative 7 squared minus 4 times 9 times negative 4, all divided by, I'm going to go ahead and simplify this, 2 times 9, which is 18. x equals 7 plus or minus the square root of, negative 7 squared is 49. This term should always be positive because you're squaring a number. When you square a number, it should be positive. Now I have negative 4 times 9 times negative 4. Negative 4 times 9 is negative 36, and negative 36 times negative 4 is going to be a positive 144, so plus 144, all divided by 18. X equals 7 plus or minus the square root of 49 plus 144 is 193 over 18. So this is where I would split it into two problems. Now notice the square root of 193 is not a perfect square. And so I could try to simplify it, but for right now, I'm just going to write my answer like this. X equals 7 plus square root of 193 over 18, and x equals 7 minus square root of 193 over 18. Those would be my two solutions. And I could put that in the calculator and get an estimate so that I could kind of know where it would be crossing on the x-axis. But if I just ask you for the solutions, that would be a sufficient answer. In fact, I would even accept this only because, again, the square root of 193 is not a whole number. It's not a perfect square. And I don't think it can be simplified. So we would leave it just like that. Last problem here, x squared plus 4x plus 3 equals 0. Again, it's already said equal to 0. So we are ready to solve. A equals 1, B equals 4, and C equals 3. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals negative, parentheses 4, plus or minus the square root of 4 squared minus 4 times 1 times 3 all over 2 times 1, which is 2. X equals negative 4 plus or minus the square root of 16. Negative 4 times 1 times 3. Negative 4 times 1 is negative 4 times 3 is minus 12 over 2. X equals negative 4 plus or minus the square root of 4 over 2. Now I split into two answers. X equals negative 4 plus 2 over 2, because the square root of 4 is 2. And x equals negative 4 minus 2 over 2. Negative 4 plus 2 is negative 2 over 2, which is negative 1. Negative 4 minus 2 is negative 6 over 2, which is negative 3. So my solutions are negative 1, 0, and negative 3, 0. Those are whole numbers. And so if we look back at our original problem, you may notice that this problem would actually be really easy to factor. Factors of 3 that add up to 4 would be 3 and 1, which is why our solutions are negative 1 and negative 3. So you do not have to use quadratic formula. If you see that you can factor it, then that's what I would do if you're comfortable with that, and we should be by now. But but you need to see that the quadratic formula also works for any quadratic function. The only example I did not show here is when there is a negative number under the square root. If you simplify, if you get to this point right here, and there's a negative number under that square root, then that means there are no real solutions. We're only concerned with real solutions in this class. If there's a negative number under the square root, that means it's imaginary, and we're not worried about that. So again, if you get a negative number under the square root, doesn't mean you did it wrong. It just means that there's no solutions for that quadratic function, which means it does not cross the x-axis. So please, when you're working these problems, write out the formula every time. Make sure you're plugging in things correctly and doing things in the right order.
I've been waiting way too long. Yeah.